All right, so the other day we talked a little bit about visible evidences, and I kept saying something about we'd talk about driving forces. There are 4 things that could happen in order to make a chemical reaction go. Now, we see what takes place with bubbles or a color change or those other things we talked about the other day, the 4 visible evidences. But now these are the 4 driving forces. I'm zoomed in a lot closer today because I want you to be able to see what's going on, and I'm going to show you some things about the lab you're going to do. But the 4 driving forces are formation of a gas. So when I mix 2 things together, if it makes bubbles, that's going to be both visible evidence, and it is what's causing that reaction to take place. The second thing that could happen, and we wouldn't normally see this, is if I mix 2 things together and one of the products is going to be water, that will be a driving force as well. So that would be something like an acid reacting with a base. Now, we haven't talked about those in a lot of detail, but if something has an H+ ion reacting with an OH- ion, that's going to form water. That's a formation of water that's taking place. That is one of the driving forces. The third thing is the formation of a solid. We talked about this the other day as a precipitation. If you see a solid forming, that is also visible evidence, but that solid forming is the driving force that's making this reaction take place. The last one is not something we can normally see under normal circumstances, and that is the transferring of electrons. Now realize that if a solid is one of our reactants and we see a reaction take place, that is going to be a driving force of a transfer of electrons. For what we're doing today in this lab, or not today, but I mean in our class in general, is we're going to be looking at the top 3 things. Do we ever see the solid forming? Do we ever see water forming? Do we ever see a gas forming? The lab that you're going to do today, or tomorrow, to whenever it is that I'm all mixed up. I don't know when this is. As you do this lab, you're going to be mixing 9 different aqueous solutions together. And you're going to be watching to see, does a reaction occur? So now, most of them you will see a reaction occur because there will either be bubbles, or there will be a precipitate, there will be a color change, or there might be some energy absorbed or released. You're not going to be able to see that one. Those are the 4 visible evidences. You will be able to see the formation of a gas, and you will be able to see the formation of a solid. I'm going to tell you that as you do this reaction, you're going to need to be able to recognize water forming. Now, I'll give you a couple little hints in class tomorrow, but again, the formation of water, we need H something reacting with something OH. If you see that showing up in a chemical formula, these 2 things are going to form water as a product. So the objective of this experiment tomorrow is you're going to take 9 different aqueous solutions, and they're in 4 different types of bottles. And you're going to be mixing all 9 things together. So the data table that you will have is going to, whoops, I put them underneath the thing. The data table is going to look like this. And you'll see that there are the 9 substances that you will list across the top, and then there's a grid. And you get to mix number 1 with number 2, and number 1 with number 3, and number 1 with number 4. And you're going to mix them in this grid, and you're going to keep track of what's going on. There will also be an unknown, and the objective is to identify what that thing happens to be. So as you mix them together, they're in 4 different types of dropper bottles. There's a big fat dropper bottle, and then there's a tall skinny dropper bottle, and then there's another short fat dropper bottle, and then the 4th kind is the one that I have to warn you about. On these, this screws off and it reveals the dropper part. And you turn it upside down, you squeeze it gently, and you release a drop or 2. I think in this experiment you're going to be mixing like 10 drops. Let me see what it says on my instructions. It says no more than 4 drops. I would say like 5 or 8 might be okay. You don't want to go crazy because we don't want to use up all of the materials. The 4th type of dropper bottle has this little red lid. If you were to unscrew this, it opens the entire thing and you will dump out all of our chemicals. For the red lid, you pull the little red lid off and then you put the little red lid back on. The same thing is true with these that have the unscrew tops that reveal the dropper. You still, every time you use this, you need to hold on to the lid and replace it immediately. If you were to use this lid on one of the other substances, you could cross-contaminate our substances and they won't work right anymore. They'll clog the little dropper. So don't think, oh, I know where it's going to be. Pick the thing up, unscrew it, use the drops, and put the lid back on immediately. So again, you're going to be mixing all of these things and you're going to watch and see, did a reaction take place? In this data table that I showed you, in this, you will be listing in these the observations that you have made. Did it form bubbles? Did it change color? Did it make a solid? Like, did it get cloudy? Or did nothing happen at all? If nothing happened, that would be no reaction, and you can write NR or a big like line just saying nothing took place. Totally up to you on how you want to do that. But again, the 9 things that you're going to be mixing, I will list them here on the board for you to see. They are calcium chloride. We'll go in order left and down and then this column. Calcium chloride, sodium bisulfite, copper 2 sulfate, sodium hydroxide, hydrochloric acid, sodium thiosulfate, which is one you've never heard of before. Like this is a pretty cool thing, but you've never heard of it. Sodium thiosulfate, sodium carbonate, ammonium carbonate, and iron 3 chloride. So now as you mix these things together, you literally are going to be doing like whatever that is, 9 by 8, like 72 different reactions, right? There's 81 boxes on here, 9 by 9, and you don't have to react number 1 with number 1 because clearly you're mixing the same thing, no reaction will take place. You don't have to react 4 with 4. That should be pretty obvious to you. And you should realize that the first time you do it, when you do 1 with 2, you're going to do it again as 2 with 1. Those are going to be the same thing, but you're going to be able to cross-check to make sure, did I do it correctly? You should get the same results in box 2, 1 as you do in 1, 2. All right? Those 2 boxes should be the same. I'm not going to tell you that you like have to do it 3 times or 4. You don't. But you do have to do it twice, 1 with 2 and 2 with 1. And it's going to take you some time to go through this whole thing. The last thing I need you to be aware of is not all of these substances can go down the drain. The copper ions, which is the blue solution, it looks like this. When you use the blue solution, that little container can't go down the drain. The copper ions could be problematic to get into our water supply. So it becomes very important that the very first time that you go to empty your little spot plate, you make sure that the copper part, the blue part, gets into a waste beaker instead. Now, if a little bit gets down the drain, it's not going to be a big deal, but we don't want a lot of this stuff going down the drain, all right? We're going to have a waste beaker at each lab station. The first, like when you get done with your experiment, you need to pour all of that stuff into the waste beaker so that it doesn't go down the drain. Now, again, if you're pouring it into the waste beaker, if it starts to get full, don't pour it down the drain, silly kids. So make sure that you take care of this because if you pour it down the drain, it could get pretty bad. And then I'd be mad at you and then I like want to punch you. I'm not going to punch you, I will want to punch you. So make sure that you're following those instructions. 9 chemicals, dropping them in. Do you know the driving forces? There are 4 driving forces. You had them written down a minute ago. Make sure you know those driving forces. Then when you get done with the experiment, this is where it's going to get a little bit more difficult. You're going to need to write balanced equations for all of the reactions that took place. That's going to take some time because it's not just like 4 reactions. There are a lot of chemical reactions that are going to occur. So you're going to have to write a balanced equation, and you'll need to tell us what the driving force was of the reaction. Again, I will help you with the predicting of products, which you should be able to start figuring out based on the types of chemical equations that we've looked at. Again, I went really, really fast because I don't want to keep talking. I want you guys to figure some things out in the lab on your own. So I will give you a little bit of instructions in class if you need them, but for the most part, you'll have a spot plate, you'll have 9 different solutions, you get to decide which one's number 1, which one's number 2, and all that stuff, and then you get to mix them together, and you get to figure out which ones have reactions and which ones don't. Hopefully this will make a little bit of sense. As I've been making this video, I realized that the chemical reactions lab report that I put onto Moodle is the wrong one. So I will be deleting that and making a new thing for you to be working on. Hope you had a great Wednesday night. We'll see you in class. Bye-bye.